What's going on, guys? It's Eric from Intelligent Quads coming back at you with another video. It's been a while since I've last posted. Work and life have been keeping me busy. In addition, I just have lost a little bit of motivation to post tutorial videos, and I've been using my free time to work on more side projects. And I've had a lot of cool ones, but I haven't felt like any of those have deserved a YouTube video until now. So one of the big problems with teaching drone programming is there's just such a steep learning curve, as well as a vast amount of different simulation tools and software tools that you have to learn and orchestrate in order to start developing your application. So one of the ideas that I've been kicking around is this idea of an online simulator. So you just go to a website, select the version of RD Pilot that you like to simulate, select the vehicle types, the location that you start, and it will spool up a simulation of that vehicle in the cloud. And the way that you will do application development in this paradigm is there will be a client that streams the Mavlink telemetry stream to your computer. From there, you can use the Mavlink telemetry stream just as you would in a typical drone development environment, whether that be with default CITL in ArtyPilot or with Gazebo, as you've seen in some of the previous videos. The advantage here is a number of things. You can get started a lot faster. You don't have to deal with setting up all the simulation infrastructure involved with getting started with your first application. In addition, the way that this is set up, it's super easy to switch between flight controls versions of ArtyPilot, as well as change to different vehicle types. In addition, my website also allows you to mix different vehicles and create heterogeneous fleets of different versions, different vehicle types, and all of that can get streamed to your computer without having to do any setup work. The only thing that you need on your side are the development tools that you want to work with, say maybe PyMavLink or maybe Mavros with ROS, or any other thing that can digest Mavlink telemetry stream. So I've made that website that I was talking about. It's at intelligentquads.com. The website is not currently ready to go, but I am looking for people who are willing to beta test, as well as any feedback that the community might have. So without further ado, let me show you how this simulator works. So when you come to my website, you'll come to the simulation tab, and then there will be a login page, but I'm already logged in. So then you'll be presented with this screen where you can configure the simulation that you'd like to run. So right now, the only flight controls available are the ArtyPilot flight controls, but in the future, I would also like to support PX4 here, and you'll be able to choose between the two. For the simulation type, right now, there's only the default ArtyPilot CITL, but there may be more coming in the future. The next thing you can choose is the vehicle type. So you can choose from rover, copter, plane, or sub. So I'm going to choose copter. And then you can also choose the flight controls version. So I'm going to go with the latest 4.2.3. And then also the model. So you have Quad X plus Heli, Octaquad, Tri, Y6. So I'm going to just go with the standard X. You can also choose how many instances of this configuration you would like to launch, as well as the location, or you can just put in a lat long altitude to start the vehicle at. So I'm going to launch it at the CMAC, which is the default starting location for CITL. So when I start the simulation, the flight controls will spool up in the cloud with the simulation. From there, I will be able to download the client, use the client to then connect to the cloud to then help bring in the Mavlink stream onto my development machine so I can start developing applications. So let's go ahead and start with just one instance right now. So I'll go ahead and press start. The next thing to do is download the client for Windows. So I have a client for Linux and Windows right now. In the future, there will be a Mac, but right now I don't have any access. I don't have access to any Mac machines to test and develop the client. So I'm going to go ahead and download this right now. There'll be a zip file. I'll go ahead and extract that. And I'll go ahead and run the app.exe. I haven't made a publisher certificate yet, so it's unknown, but this will be fixed in the future. Okay, so now the client is running. So I'm basically presented with this window, which I can then take the unique ID of my simulation instance and paste it here into the application window, and it will go ahead and make the connection to the server. So in this window, you can see that it's made a connection because it says that a Mavlink stream has appeared. Now that we're bringing the Mavlink stream into our computer, we can go ahead and launch Q ground control. And sweet, it looks like we have a simulation here. So this works just like the default CIDL in ArduPilot if it was installed locally. So we can go ahead and give it a takeoff command. And it should start to take off. We can also send it to locations. And we can just command it as normal. Sweet. So basically now I've showed you that you can use the Q ground control app to control our simulated drone. The other cool thing is we can actually do a development. So in previous videos, I've been showing you how to use PyMavlink to control and get telemetry from your vehicle. So this will also work with that. So let me go ahead and go to one of the previous applications that I've written. So I'll go ahead and open up the IQ PyMavlink tutorials. So let me go ahead and look at the listen.py. So right now it's configured to accept from 14550, which that is also the port that Q ground control is using right now. So I can use one of the other ones that comes out of this client. So let me use 14551 for this connection. So now I can come back to my terminal and just run Python and then listen. And now I'm getting telemetry from the vehicle. And similar, we can also use these Python scripts to command the vehicle as well. So let's take a look at takeoff, which I'm looking at 14551, so that looks like it should work. So let's do Python and then takeoff. And it looks like it probably did not work because we have to set the mode to guided. But once we do that, we can rerun the script. And it looks like the vehicle begins to take off. Another cool thing you can do with the simulation is you can use Whistle with ROS to do development. So let me go ahead and open up Ubuntu 20 on Windows, and then the next thing I'm going to need to do is type ifconfig. And on Whistle, you get a unique IP address for your Whistle instance that is separate from the host. So for our Mavlink stream, we'll have to use the client to forward the UDP Mavlink stream to Whistle. So let's go ahead and use Mavlink 3, and then we'll set this to 14550, and then hit connect again. So we can go ahead and launch up Mavros. So let's type in ROS launch, IQ sim, apm.launch. And now we have ROS running on Whistle. So let's go ahead and open up another terminal. And now we can use ROS topic echo to look at, or ROS topic list to look at the different topics that are available. And we see the typical topics that we usually do in the other videos. So now we can actually run some of the programs that we've made in the past, such as ROS run, IQ, GNC, and then square, and it should run the program that we've made in the past. So now we can set the mode to guided over here. And we can come back to this instance, and it looks like the drone is arming and going to run our square program. The next thing I want to show is that the IQ simulation website is possible of doing heterogeneous and multi-vehicle simulations. To demonstrate this, I'm going to go ahead and make a simulation with 2 quadcopters and 1 plane instance. And I'm going to also run the instances in different parts of the world. So let's go through the configuration real quick. So I'm going to be using ArduPilot, default Citadel, then I'm going to set this to ArduCopter, and then I'm going to set this to the latest version. I'm going to use X, and then I'm also going to set this to 2 instances, and then from here, I'm going to set the location to CMAC for the first one. And then for the plane configuration, I'm going to go ahead and hit the plus tab up here. And then I'm going to go down to here, select ArduPlane, select the latest version of ArduPlane, have instance 1, and then I'll have this one fly in the University of Chicago. So let's go ahead and start this simulation. And take the UID, go ahead and open up the client, paste that in there, hit connect, and then we can go ahead and take a look at Q ground control, and in a minute or two, all the vehicles should connect. So up here we have a tab with vehicle 1, 2, and 3. So it looks like vehicle 1 is there, vehicle 2 is right on top of vehicle 1. So if we zoom in, you can see that it says vehicle 1 and 2 right on top of each other. And then vehicle 3 is going to be all the way across the world in a different location. Let me give my computer a second to load the map. So this is the University of Chicago. Let's zoom out some more. Give it a second. So that's the United States. And then CMAC should be in Australia. So now in one simulation, we're running 3 vehicles in 2 very different parts of the world. And the really cool thing about this is we can do all the development that we did previously with one instance, as well as use Q ground control to control all the drones. So with vehicle 3, I'll go ahead and set this to guided. Oh, actually, this is a plane. So the best way to take it off that I found is to create a mission. You'll have to excuse me because I'm not as familiar with RDPlane as I am with Copter, but the best way that I've noticed is to upload a mission and then run the mission to get it to take off. So if we zoom in again, we should see the plane starting to fly. And we can give it commands just as we would with a quadcopter. And so if I tell it to come over to here, it should go fly to that point and then start a loiter pattern. Now let's go ahead and manage our other vehicles. So let's go to the quadcopter here. It's available to be commanded to take off. So give it a second, starts to take off. And we can also send this to different locations. So overall, I'm very excited about the Intelligent Quads online simulator. It has a lot of different features and a lot of different potential for development, and hopefully this can really streamline you guys' development processes. In the future, I want to add more things like a visualizer similar to Gazebo that will also be web-based, as well as a 3D physics world so that we can land on objects and we can see the objects and those types of things. But for now, we're just running the simple ArduPilot Citadel in the cloud. And this is really cool because you don't have to do that much setup. It supports multiple platforms, runs on Linux, Windows, and it just should streamline your guys' development process. So in the description below, I've put a link to a forum where you can sign up to be a beta tester, as well as leave feedback. So please let me know what you think. And until next time, keep it cool.